Can you hear me?
Yep.
Yes. Hey everyone, thanks for coming out, coming to Netflix. We will talk a little bit about LinkedIn and how we do media processing. I think it's very different from what Netflix is trying to do in that media obviously is not our main product. We also don't have a lot of our internal users who want to understand all the ins and outs of media processing. So we as a team do this for them. So who am I and why am I here? My name is Hans. I run the media processing team at LinkedIn. I actually used to work at Netflix 10 years ago. I remember some of these things that were discussed. It was a beautiful time. I also been doing a lot of work with Roku and Movie Labs around standards metadata for movies. Been about a year at LinkedIn. Before that, I spent 3 years leading the performance team, which is an internal team to make things faster and more efficient and cost-effective, etc. So when you talk about LinkedIn, maybe you wonder, like, what is the media at LinkedIn? I'm sure some of you use LinkedIn. I'm sure some of you occasionally go to LinkedIn, not only when you're looking for a job. Media is actually everywhere on LinkedIn today. So if you go to the feed, we call the main page the feed, you see there are images and videos everywhere. And as such, since a lot of this is generated by users, we also deal with the problem of user-generated content being of questionable standard. We also have something called documents. LinkedIn being a professional network, one of the things that we deal with a lot is documents. These, I don't know if you can see, are two examples of great documents that are shared on our feed. For instance, the initial pitch deck for Uber 2008, shared and reshared thousands of times. What happens when you have a PowerPoint file today or a Word document that you want to share? It's really difficult to do this. So we take care of taking this in, turning it into a format that is easily shareable, typically as a PDF or maybe JPEGs that you can page back and forth and annotate and share. Like I mentioned, we have a few use cases. We have images, documents, videos on the feed. We also have profile pictures. I'm sure you've seen those. Backgrounds on the profiles. We have company pages. We have backgrounds to the company logos, etc. We also have messaging. You can send messages back and forth and attach videos and documents and audio and images and blobs. We also have our video ads. And for those of you who have seen the learning stuff that we have on linkedin.com/learning, we also have pretty nice set of higher quality videos that are not generated by users. So just to get a sense of scale at LinkedIn, we do have quite a number of members in many different countries. 645 million members is the latest official number. We have 163 of those here in the United States. 30 million companies have listed, and we have about 20 million-ish jobs at any given time on our website. You can see more there on linkedin.com about us. So what then is media infra at LinkedIn? It is our processing, pipeline, and serving framework. So we have unified this into one single thing that our customers can use. And our customers are internal teams that want to process and analyze video, images, documents, as well as external, members upload stuff and share on their feed. And we do everything. We ingest, analyze, process, we store and serve. And since we are a member-facing company, we also have to deal with deletes, etc., of data in the right way based on data privacy laws and so on. So what were the design goals of our infrastructure? Well, the first was to unify our processing and serving. Before we started with this endeavor, it was kind of Wild West at LinkedIn. Every team who needed to deal with media in any form would do it the way they wanted. They would store it. They would potentially forget about this being stored, and then it would never be deleted, etc. So we unified this. We also started with images and video and built it to handle the unknown. If you remember a few slides ago, we talked about documents. That was not part of the initial idea of it, but we designed it so that documents would be processable and servable using this infrastructure. We also designed it to not just store the media and the associated media artifacts that you get when you, for instance, process a video into multiple bit rates, but also the metadata associated with this so that we can keep it all in one place. We, further for the design goals, were pluggable interfaces. For those of you who code in Java, we would supply the interfaces, and then to these we would create various types of implementations so that when we define our workflows, we can abstract the what from the how. Further goal was to support on-premise as well as cloud models. We wanted to not tie ourselves to any specific cloud. We wanted to make sure that any cloud provider who has any good functionality can be represented in our framework. Plus, we built it for a future open sourcing of this. So how do we do this? Well, we have something called a recipe. A recipe is really a workflow. It's a set of ingredients or dependencies and the steps that you need to process to get into your final form. So for each step in this, the output then becomes the input. Like I mentioned, we built it so that we could have a best of model where we would look at where is the best place to store this data, where is the best place to process it, where is the best place to analyze it or to extract relevance out of media. And finally, we built it so that we could have for those of you who know RESTly, we built it using our framework for RESTful services so that it's easily documentable and usable. So what happens then? What is this recipe? Well, first, a customer defines and provides a recipe. They can either use a template or write their own. And we would then take this and process the media according to this recipe. In this recipe, we have something we call an asset. And maybe this is a slightly different definition than Netflix has. But for us, the asset is the overall incoming media. This is then processed into one or several artifacts. And an artifact can be media renditions of this, for instance, different sizes of JPEGs on a profile picture, or it can be data, metadata around this JPEG. For instance, pretty much like what you find in an EXIF, for instance, in an image. Our recipes are finite state machines. There are graphs where each node then defines the required and optional input, the dependencies, and then declares what the outputs are for each of those. An asset then becomes available when all these required artifacts, and remember the artifacts are the things that are being processed through this workflow, when they are available. We also have something called optional artifacts that we generate, and they do not determine the state of the asset. They're optional. So when every dependency is satisfied, we then have an available asset. So this is all very abstract. So let's see if we can have a little bit of a picture to illustrate. So what you see here in blue and gray is actually our internal visualization of a recipe. And in this specific little snippet, we have two types. We have blue, which is media processing, and gray, which is metadata processing. And as you can see, it starts at the bottom. You provide a video of some type. It then goes through a few triggers that are internal, and then we render adaptive bit rates, different types of bit rates. In this specific recipe, we cap it at 3,300 kilobit, for instance. We also run it through our relevance and classifications framework on the right side. So we do this to ensure that content is appropriate. For instance, people upload things that should not be visible, and we spend a lot of time making sure that there is no spam or other unsavory content on what's being uploaded. We classify content. We assign different types of scores to it to make sure that we show what we want to show. Just for your information, the dashed lines in this are somewhat optional. The solid ones are never optional. So what is the architecture of this? The architecture of this, very simplified, is the following. The user up in the left wishes to share a video on LinkedIn. It then calls into what we call the asset manager. This is the content asset manager that handles and knows about all types of media at LinkedIn. It gets back an upload URL. Because of the way we have defined this system, the upload URL could be to one of the public clouds, or it could be into one of our internal systems. The system itself doesn't really care. What happens when this is uploaded, we have wrappers around these external cloud to signal back when upload has happened. And then the asset manager knows which recipe to engage. This recipe then kicks a few different types of processors. In this simplified case, it's just a video that runs in a video processor cluster. This then will call into different services according to the recipe, get the data out of the associated storage. And again, this can be across different cloud, on-premise. The system is blissfully unaware of this. And then when all of this is done, it signals the status back to the asset manager, at which point the user can ask for the streaming URL. So what are the challenges that we face? Well, we have very different type of inputs. I think we are the inverse of Netflix, where people who want to have their content on Netflix probably provide the absolute best master that they can provide. We do not have that. We have about 50 different codecs. We have codecs that are so obscure we have to look them up and figure out what they do. We have unknown quality. We have people uploading 50 megabyte images. We have people uploading 200 byte size JPEGs, GIFs. So we have to deal with all this. We have to make sure we understand what we do, because for some of our customers, they have different requirements on the quality that they accept. We also have to understand the challenges of on-premise versus cloud. And of course, there is a cost associated to all of this. It may be that it's actually cheaper to store things in a public cloud than it is to store it on-premise. It may be that we get better quality if we process it internally versus in some of the available cloud services, etc. So we need to care about this. We need to care about latency, obviously. People don't want to upload videos and then wait an hour before they're visible in the feed. But also, which is very important, is the speed of innovation. Right? So once you abstract all this functionality and you make it possible to choose and pick the best of, you are able to innovate faster. You can almost do what we do with CDNs, where we kind of shift traffic based on what's best at the very moment. So how do we handle this mixed deployment? Well, we have a type of recipe where we can actually run recipes in parallel through something called alternate recipes. And we do this, we can dual process. So for instance, if we want to see is cloud number 1 better than cloud number 2, we can run this in parallel and A/B test and verify. We also have to deal with variance of performance. For instance, if you call into an internal service to extract relevance out of an image, it's probably easier for you to have an upper bound of the latency that you expect than if you call into some cloud providers' APIs. You don't have to deal with the network, etc. And so we have to make sure we understand what that cost is. And we do this by not just looking at operational, traditional latency metrics or availability and all these good data infra style metrics, but we also have to look at business metrics. Every business has their own metrics that they follow. Typically, we look at how many of our members are engaged, etc. Netflix probably looks at number of hours of video streamed, if that is still the metric used. So we have to make sure we look at both of these. Now, a few months ago, we actually went live with LinkedIn Live. I don't know how many of you know this. We have kept it very whitelisted for now because we want to make sure we understand the entire business of this and how it impacts our users on the feed, etc. We also have, of course, when it's live, as you are probably aware of, there have been a few instances in the last few months of people live broadcasting things that should never be live broadcast. And so we're trying to figure out how to best deal with that. But we had this live, and of course, the first challenge that we faced is, okay, we believe we created this infrastructure that is so wonderfully flexible and great. But does it actually handle live? What do you think? Yes. Of course it does. So here is a very simplified, and apologies to the manager who's actually handling this. I'm sorry I simplified this. But you have a camera, you want to broadcast. What do? You call in the same way you call in if you upload an image or a video. You call into the asset manager. The asset manager, and here is a beautiful thing about our infrastructure, actually calls itself to create an asset. This asset is the thing that tracks this live stream. It calls into Azure, and here I can actually talk about our concrete cloud provider because we have built this on top of Azure. We allocate an ingestion server. We get one back. We return that to the camera who can then broadcast using RTMP into this ingestion server. When this is going well, we can then easily, through Asset Manager, return the streaming URL to the actual user. And then later when this video broadcast has been concluded, we can turn it into a video on demand. The challenges that we face with this, obviously, is did it work with our infra? And yes, it did. The other one is how do you select the best ingestion server? Since we're calling into a sort of unknown world of the Azure media services, how do we know that we get the best ingestion server? And that was a little bit of a challenge. We also had to scale for millions of viewers. How do you do that when we never really scaled anything like that before, especially live? And of course, distributed systems are fun, as you know. We get out of order and missing events we have to handle. We get broadcasters who suddenly just disconnect their cameras and wonder what happened. We needed to figure out how to tune the Azure live functionality with our LinkedIn functionality. It was interesting. And then the last bit about traffic shifts is that at LinkedIn, we frequently shift traffic between our different data centers to make sure that we can understand pain points of scaling, to make sure we can survive if one data center goes down. And those happen pretty much like a chaos monkey would. And we need to deal with that. So that was interesting when we deal with live streams because obviously any lag or disruptions are very unnerving. We also have our own co-locations, our colos, if they're available or not, we have to deal with. So to summarize, what are we doing at LinkedIn? Well, we built this one framework. We wanted to unify everything that we had into processing and serving. We built it using something called recipes, which is a description of workflow where we have assets and their associated artifacts and the dependencies between these. We have the concept of required and optional dependencies, and we also can do alternate recipes to make sure we parallelize processing in our framework. And again, we provide the interfaces and then implement them using the best of idea. Again, The way we pick and choose is by looking at the cost, the quality, the latency, and the speed of innovation. And remember to always look at operational and business metrics. That's it. Questions? Thanks.
Fantastic presentation.
Thank you.
This sounds like the kind of problem that you wouldn't want to solve from a clean sheet of paper, ground up. Were there open source libraries or frameworks that you leveraged to build this system?
Yes. Of course, yes. So as we are building this, I know, for instance, Netflix has Conductor, right? There is a bunch of different workflow engines around that we certainly have looked at. We may get to a point in the future where we will revisit a little bit of this, but we have an interesting infrastructure at LinkedIn that we have built this to incorporate. Obviously, for some of the, I'm sorry, I'm a bit abstract here because I can't really talk about this too much, but there are some common tools that we use in media processing, open source. There are a few that are well known and used by everyone. And we may or may not use those as well. But I don't think we've spent a lot of time rewriting many of those.
Okay, can you hear me now?
Yes.
So my first part of my question is, what is the end-to-end latency from the camera all the way up to the consumer? Second one is that I think you already answered my second question. What are these components of your architecture and infrastructure? I mean, can you give it a little more details and colors about those things? What part you had to build? What part you could actually use open? Throw in some names which are well known, so you may or may not use those, but that'll be helpful.
So the first question was, what is the latency from the camera to the delivery of live? Is that the specific context? It's really fast. I don't know what. Sorry, I haven't prepped what's publicly available about these numbers, but I can figure out if you look me up after this. For the second one, I think the question was, okay, what exactly are we using? Is that I think if you go to GitHub, you find a few of them. I'm sorry, I can't really talk about it. One of the problems that we have when we have user-generated content is that we have a tremendous amount of attacks coming in through media. I think there are, for instance, if you use a tool like FFmpeg, there is a bunch of well-publicized attacks on it. Like how do you handle when someone crafts something that looks like an MP4 and it's based on, its purpose is to assume that you run on some version of Linux and it crashes it to just gain control of the host and do things. And so that's why it's hard to express exactly what we're using. I know that some cloud providers use, for instance, they use FFmpeg, some cloud providers, and they provide their own hardened versions of them. And it's all very hush-hush because it's a real and present danger.
So my question was almost exactly what you just answered about security. How do you deal with security and sources that you don't trust?
So we do, if I just go back to this. First of all, we treat everything that comes in, unless it is from something that we produce internally, we treat it as hostile, right? We have to treat it as if it can contain anything. We need to make sure we minimize the surface of attack. We do it by defense in depth. We have different ways of We classify, if you can see on the right side, we do a lot of scanning analysis. We look at different types of content. We look for the obvious things that you do when you handle user-supplied input, like antivirus and all this. But we also have a tremendous amount of checks on the data, that, on the bits that come in. We then make sure that it's processed in the most isolated environment as possible. A lot of that, by definition, is something I can't really talk about, but it's exciting. We work very closely with the security teams at LinkedIn on coming up with this. So they help us understand what the attacks are and what we need to do. How much more time do we have?